prove that root 2, root 3 are irrational numbers. So for this question, first let us prove root 2 as a irrational number. So in order to prove root 2 as irrational number, the first step is we need to assume that it is a rational number. The reason why we are assuming this is so that we can write root 2 in the form of p by q. For rational numbers, there is a standard form of p by q. For irrational numbers, there is no standard form. So if we assume root 2 as a rational number, we can find two numbers p and q such that root 2 is equal to p by q, where both p and q are integers. They belong to integers and q is not equal to 0. So once we have assumed root 2 as a rational number and we wrote it as p by q form, we can now divide it with HCF of p and q. What happens when we divide p and q with their HCF is they form two different variables a and b, where a and b are co-prime. Co-prime means a and b are numbers which does not have any common factors. Now we have written root 2 is equal to a and b, where a and b are co-prime numbers. They have no common factors. We have root 2 is equal to a divided by b, and this can be rewritten as by squaring on both sides. By squaring on both sides, we can get 2 is equal to a square by b square, and this can be rewritten as 2b square is equal to a square. So from this equation, we can conclude that 2 is a factor of a square. Since a is equal to 2 into b square, where b is a integer, we have to assume that 2 is a factor of we have to conclude that 2 is a factor of a square. But if 2 is a factor of a square, then according to fundamental theorem of arithmetic, says that every number has a unique set of prime factors. So if 2 is a factor of a square, then 2 is also a factor of a. So we have this conclusion. From this we can write a is equal to 2c. Since 2 is a factor of a, we can write a is equal to 2 into some other number. We have this as equation 1. Now let's square equation 1. Sorry, let us substitute. Let us have this as equation 1 and this as equation 1 and this as equation 2. Now we will substitute the value of a in equation 1. So substituting equation 2 in 1, we get 2b square is equal to, and a square will be 2c the whole square. That gives us 2b square is equal to 4c square, which means b square is equal to 2c square. Again, we have b square is equal to 2 into some other number. So 2 is a factor of b square. So 2 is also a factor of b. So we just found out that 2 is a factor of a, but if we but we are also getting 2 is a factor of b. So a and b are co-prime, but both a and b has 2 as a factor. So what we are getting is a contradiction. We assumed that root 2 is irrational. From that we written root 2 is equal to a by b, where a and b are co-prime numbers. But now we are getting a and b has 2 as a factor. So we can conclude that this contradiction occurs because of a wrong assumption. Hence root 2 is irrational. So we assumed root 2 as a rational number, and we wrote root 2 is equal to p by q, where p and q belongs to integers and q is not equal to 0. By dividing with the HC, we got a and b, which are co-prime numbers. So 2b square is equal to a square. That means 2 is a factor of a square as well as a. But by assuming a is equal to 2c, we got b square is equal to 2c square. So 2 is a factor of b as well. Since a and b are co-prime, they cannot have 2 as a common factor. So the contradiction occurs because of a wrong assumption, and root 2 is irrational number. Same method and the same way we can prove root 3 as a irrational number. So now we'll try to prove root 3 as a irrational number. The same way we will first assume root 3 rational. By assuming this, we can write root 3 as p by q, where p and q belongs to integers and q is not equal to 0. We can find two variables a and b which are co-prime, and we can write root 3 as a by b, where a and b are co-prime numbers. So by assuming this, we can get root 3 into b is equal to a. So root 3b is equal to a, and squaring we get 3b square is equal to a square. So 3 is a factor of a square. So according to three into some b square is equal to a square, so we can conclude 3 is a factor of a, and also according to fundamental theorem of arithmetic, 3 is a factor of a. So we can write a as 3c, 3 into some number. This is equation 1. Now we got a is equal to 3c. By squaring on both sides, we get a square is equal to 3c square will be 3 square will be 9 and c square. Now we are going to substitute this a square in 1. Substituting a square value in 1, we will get 3b square is equal to a square is 9c square. So 3b square is 9c square, which gives us b square will be 3c square. So from this equation we can get 3 is a factor of b square. So consequently, according to fundamental theorem of arithmetic, 3 is also a factor of b. Now again, both a and b has 3 as a factor. But a and b are supposed to be co-prime numbers. So this contradiction occurs because of a wrong assumption. Hence, root 3 is an irrational number. So if you have any doubts in how to prove root 2 or root 3 as irrational number, feel free to discuss in the comment section. We'll try to help solve it. Thank you.